So, I'm driving to school this morning and I'm thinking, why is it that students can solve equations, a system of equations like the one you see here, but when it's a story problem and it takes up a paragraph in their book and all of a sudden it's tough and different? That's what this video is all about. This will be like magic, so I hope you're sitting down. Okay? We're going to make connections between solving systems of equations and story problems. So first we need a system of equations. So let's do this. There's a nice little system of two linear equations with all positive whole numbers, nice and easy. Why don't you go ahead and copy that down. Pause the video, go ahead and work out the answer. Okay? See you in a minute. Alright, you're back. Let's just check and make sure you got the right answer and you're familiar with this little technique. Okay, we're just going to balance out the equation. We want x's on one side, numbers on the other. This is all kind of review for us. Or maybe not. Maybe this is brand new for you. I don't know. Through the magic of YouTube, I don't know what your background is. Okay, so I get that solution, x equals 4. Through using opposites and inverse operations. Great, great. Okay, next step is, hopefully you know how to do a proof. That just means now that we have an answer, or we think it's the answer, there's a way to prove it. Can you do that? Go ahead and do that. Pause the video, make the proof. I'll show you how in just a second. Alright, let's do the proof. You zoom out, we can capture the whole process. A proof simply means take these original equations and substitute what you got for x, your potential solution, substitute it in there, and if the two sides are equal, which they are in this case, that means your solution is true and there's your proof. Okay? Now if the proof is not equal, that could mean a number of things. It could mean there's no solutions, it could mean you made a mistake, all kinds of things. But for the purpose of this video, it's true, and hopefully you got 18 for that. Okay? Now if you don't have all this on your paper, it's super important that you get it copied down now. So if you don't have it, pause the video, copy this stuff down. We got to make sure you have this before we move forward. And pause. Welcome back. Guess what's happening now? We have a fantastic story problem for you. Ah, yeah. Here's where it gets fun. Okay. So here's a little story about a couple of gas stations. We've got the Dino Drive. Sells gas for $4 a gallon. When you purchase it with a $2 car wash. It's a package deal. Across the street, Fred's Fuelorama charges $10 for the car wash, but they'll sell you gas for $2 a gallon as long as you buy the car wash. Once again, a package deal. You can't opt out. The prices are linked together. So, your job, you're going to write an equation for the total cost at each gas station. So you're going to have two different equations. Then you're going to solve. And you're going to find out after how many gallons of gas will the total price be the same at each station. And then a step further, what will that price be? Finally, you're going to graph both stations. The lines that represent each station, you're going to put them both on the same graph. Find the point of intersection and describe what that means in this situation. Then I have one final follow-up question there. Which station is the best deal after 10 gallons? Now I want your goal here to be, don't make a table. No table. Okay? Use algebra to do this. Okay. So make sure you get all the important information, all the numbers down, and pause it again, do your work, and I'll be right back. Okay, that's good enough. And you're back. How did that go? First, I'm going to pull up as a little review our original equation there. And I'm going to make a couple of alterations. How many of you caught this? Come on now. Did you catch this? The story problem is the exact same problem I gave you in the first place that we did in blue here. I'm just using red to show you what pieces of the story problem are showing up in the original algebra system of equations that we did. Okay? And here is the connection I want you to make. Okay? If you're having an easy time doing the algebra but a hard time with story problems and graphing, here's the connection. Okay? When you solve the problem, that is the x-coordinate for the intersection of the two lines on the graph. And we'll graph these in a second. I'll prove this for you. So you solve it, that's the x value, right? You prove it, that's the y value. That's the x and the y that make both equations true. That's why this 4 solves both of these over here, and that's why both sides of this are 18 when you substitute the 4 in there. Okay? So our point of intersection is 4 and 18. And we don't need a table for that, and we don't need a graph for that. Okay? We can put it on a graph, and that's what we're going to do now. This is huge! I'm about to explode. I'm so excited about this. Okay? Here's the connection between doing the letters and numbers with no emotional attachment, like a robot or a monkey, and doing the problems that have a little bit of personality in them and lots of words. Please understand, it's all the same problem. It's the same thing. So, by solving this, we've come up with the gallons. And the reason we know this is gallons is in the story it says price per gallon. Okay? And we know that the word per, that means multiply. It's also something a cat does, but it's spelled differently. Per means multiply. Per, each, every, like if I said $2 a gallon, you know, those types of words, they all tell you to multiply. That's how we know x is gallons. And plus, since the form we're using here, y equals mx plus b, that's the only spot in the equation where there's multiplying going on. So we know that that's the x because there it is right there. The m, the slope, the rate of change, that's the price for each gallon. So there we go. Let's make a graph of this situation. Let me show you how easy making a graph is once you understand this. Okay, what's the x? Gallons, right? Okay, the y is the price. That was the proof up here, okay? So in order to capture this whole problem on this tiny little graph, I need at least 4 gallons. There's the 4. I'm going to go farther just to make sure I get everything. What about the money? I need to go at least up to $18, but I'm going to go higher than that. So I'm going to count by, twos. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. There we go. Step 1, There's the intersection. We know that that dot on the graph is going to go with both gas stations. 4, 18. That's the intersection. Might as well just write that word there right now. And what I want you to get with this is when you're reading the story problem, you can already picture the equations. You picture what they mean. For example, Dino Drive, the $2 car wash, that goes right here. That's the initial value. That's the b of y equals mx plus b. And if I have that, and I figured out algebraically the intersection, I know I can use those two dots and make this line, and it's going to be correct. Okay? I'm going to color code this for Fuelorama. Fuelorama, $10 car wash, that's the y-intercept. Okay, that's right here. Y-intercept, I have my common point of intersection between the two lines. Okay, so the red line, that's Fuelorama, and the blue line, that's Dino Drive. That's how simple making a graph in these situations is. If you have the intersection and you have the two equations, that's all you need. Okay. So let's make sure you get the big idea here. The big idea. Right? All we're trying to do is link these systems, this, that you're good at, you know how to solve, you know how to prove, link that to those story problems by understanding that the solution and the proof are the x and the y value of the intersection of the two lines. And that once you have that, you can graph everything and answer all kinds of crazy questions and not be scared of all those words on the paper. Okay? Whoo! Write this day down in your diary. Snap a picture of this. That's your new wallpaper for your phone. That's it. Okay? Thanks for watching, and apply this concept to those problems you're doing in class. All right? See you later. Bye.